Alright, problem number 1, part A. Diagonals of a trapezoid are congruent. Well, if it happens to be an isosceles trapezoid, remember an isosceles trapezoid would be one where the legs are congruent. If it's an isosceles trapezoid, then the diagonals are congruent. So this will be congruent to this. But only for an isosceles trapezoid. If this is not an isosceles trapezoid, let's see, can I change this? No, not really. If it's not an isosceles trapezoid, then the diagonals will not be congruent. So this is going to be sometimes true. Opposite sides of a rectangle are always congruent. Alright, a rectangle is a parallelogram, and that's one of the properties of a parallelogram. A square is a rectangle. Yeah, a square is always a rectangle. What is the definition of a rectangle? The definition of a rectangle is a quadrilateral with 4 right angles. A square always has 4 right angles, so it will always be a rectangle. A square is a rhombus. A square is always a rhombus. Okay, what's the definition of a rhombus? Something quadrilateral with 4 congruent sides. A square always has 4 congruent sides, so it's always a rhombus. All angles of a parallelogram are congruent. That will certainly not always be true. Okay, that will sometimes be true. If I draw a general parallelogram, okay, in this parallelogram, are all angles congruent? Obviously not. I have an acute angle, obtuse angle, acute angle, obtuse angle. So those are not all congruent. But if I make this parallelogram a rectangle, which is a special case of a parallelogram, then I have 4 90-degree angles. So these will be all congruent. So under those circumstances, it would be true. So that's why sometimes. If it happens to be a rectangle, all the angles are congruent. If it's not a rectangle, then the angles are not congruent. Opposite angles of an isosceles trapezoid are congruent. That's going to be never. Okay, again, here's my isosceles trapezoid, and opposite angles would be like this angle and this angle. There's no way these angles are ever going to be congruent for an isosceles trapezoid, so that's never. Diagonals of a parallelogram are perpendicular. That's going to be sometimes. Okay, do you know any shapes that have the property of having perpendicular diagonals? I can think of 2 shapes that have that property. A rhombus, like this one, is a rhombus. A rhombus and a kite both have the property that the diagonals are perpendicular. Okay, so the diagonals of a rhombus are definitely perpendicular. And a rhombus is a special kind of parallelogram. So in general, if I have some just general parallelogram like this, in general the diagonals are not congruent. I mean, not perpendicular. Okay, so, well, that looks a little bit too much. Let's stretch this out. Alright, if I look at the diagonals of this thing, okay, here's a diagonal, and here's a diagonal. Okay, so for your basic general parallelogram, you can see just by looking at it that these are not perpendicular. This is an acute angle, this is an obtuse angle, this is not 90 degrees. But if I make this so that it's a rhombus, if I make it shorter until I'm trying to make it so that it has 4 congruent sides as best I can. If I make this more of a rhombus, okay, now let's take another look at those diagonals as I rhombus it up a little bit. Okay, the more I turn this into a rhombus, okay, the more you can see that now it looks like these diagonals are perpendicular. So if it's a rhombus, the diagonals will be perpendicular. If it's not a rhombus, the diagonals will not be perpendicular. So that's why for a parallelogram, the diagonals are sometimes perpendicular. Okay, which two segments or angles must be congruent to enable you to prove that ABCD is the given quadrilateral? Explain your reasoning. There may be more than one right answer. So, looking at this ABCD, we want to prove that this is a rectangle. Well, the definition of a rectangle is 4 90-degree angles, but that doesn't have anything to do with, well, you know what? Yeah, that's one way to do it. So, which segments or angles? If we could show that angle A, angle B, angle C, and angle D were all congruent, that would mean they all had to be 90 degrees, which would prove this was a rectangle. So one way would be to say that angle A is congruent to angle B and congruent to angle C and congruent to angle D. Okay? And the explanation would be if they are all congruent, they must be 90 degrees each. Okay, so that's one way that we could prove this is a rectangle. Or we could use the special property of a rectangle. Do you remember what the special property of a rectangle is? Let me change colors for this. The special property for a rectangle is that the diagonals have to be congruent. So this parallelogram will be a rectangle if the diagonals are congruent. So the diagonals here are AC and DB. So if AC is congruent to DB, the fact that the diagonals are congruent means it's a rectangle. Okay, for this shape to be a kite, we have these consecutive sides congruent. I see the symmetry with these angles congruent. But for this to be a kite, these last two segments would need to be congruent, the other pair of consecutive sides. So segment AB would need to be congruent to segment AD. And that's just because of the definition of a kite. For this to be an isosceles trapezoid, angle B would have to be 56 degrees to match this, and angle C would have to be 124 degrees. Okay, and that would make this an isosceles trapezoid. So I guess we could say that angle A would have to be congruent to angle B, and angle D would have to be congruent to angle C. Okay, find the length or angle measure. WXYZ is a square. If I were you, I would draw that. Okay, so there's our square. So this is WXYZ. Now, WX is 1 minus 10x. Okay, so this is 1 minus 10x right here. YZ is 14 plus 3x. Okay, so this is 14 plus 3x. Well, if this is a square, then all 4 of these sides are congruent. That means definitely the opposite sides are congruent. So we can make an equation. So 1 minus 10x should equal 14 plus 3x, as these opposite sides are definitely congruent. Okay, I'm going to add 10x to both sides. So that's going to make 1 equals 14 plus 13x. If I subtract 14 from both sides, okay, that's going to give me negative 13 equals 13x. If I divide both sides by 13, then that's going to give me negative 1. X equals negative 1. But that's not the answer to the question. We're supposed to say what the value of xy is. So we have to take this x and plug it in. Okay, so if I take this and plug it in, then that's going to give me 1 minus 10 times negative 1. Okay, that is 11. Alright, so that's why the answer is 11. Okay, WXYZ is a rhombus. Okay, so this will be, let's call this WXYZ. Here's my rhombus. Okay, so angle X is 24 times 10 minus X. So this is 24 times 10 minus X. Alright, is this angle right here. And then angle Z is 6 times X plus 15. So this is 6 times X plus 15. Alright, and that's this angle right here. So this is a rhombus, which is a parallelogram. So opposite angles will be congruent. So we can definitely make this equation. So that means 24 times 10 minus x should equal 6 times x plus 15. If we do the distributive property twice, okay, that's going to give us 240 minus 24x is equal to 6x plus 90. Okay, so I'm going to add 24x to both sides to get these x's together. Okay, so that's going to cancel each other out. So that's going to give me 240 equals 30x. Alright, that's my 6x plus 24x plus 90. Alright, then I could subtract 90 from both sides. So minus 90 minus 90 okay, so that is 150 equals 30x. Time to divide by 30. Alright, so that's going to give us x equals 5. So x equals 5. But again, that is not the final answer. We are supposed to be finding the measure of angle y. Okay, so the measure of angle y is this angle over here. Okay, this is the one that we want. But these will be supplementary. So this is the deal. Okay, I've copied the rhombus over so I can put stuff in it. If x is 5, then I could just plug 5 in right here for x. So that's going to make this become 6. Let me just make myself some space here. That's going to make this become 6 times 5 plus 15. So that's going to be 6 times 20. Okay, so that's going to be 120. Okay, so that means, alright, if I plug this in and got 120, that means these angles are 120. So this is 120 degrees, and this is 120 degrees. Okay? But these angles will be supplementary. Okay? Consecutive angles in a parallelogram will be supplementary. So I could just do 180 minus 120. And that, if I do that, that's going to make 60. Okay, so angle y must be 60 degrees. Alright, so that's how you find the measure of angle y. Okay, WXYZ is a rectangle, so let's draw a rectangle. Okay, so there's a rectangle. WXYZ is a rectangle. So, fine, here's W, X, Y, Z. Now, when we do this math, just understand that I've randomly put these letters on here. But this side that I've drawn to be longer, this could turn out to be the short side. So don't worry about the fact that the picture may or may not match what the numbers give us, because this is just a model. same thing over here. We got that this angle was 120, but this is clearly, the way I drew it, it turned out to be, this was an acute angle in the diagram, but it came out to be an obtuse angle once I found the numbers. But that shouldn't bother you because we picked the letters randomly, so you never know how it's going to turn out when you do that. We are being asked to consider the perimeter of triangle XYZ is 24. So look, we're talking about this triangle, not the whole rectangle, the perimeter of just the triangle XYZ is 24. So what does perimeter mean? Perimeter means what you get when you add up all the sides. So in this case, we're saying that if we add side XY plus side YZ, so we have XY, YZ plus XZ, that should be the perimeter. XY, YZ, XZ, that's the three sides. And according to the problem, the perimeter is 24. So the sum of these three numbers should equal 24. Okay, but they've given us some additional information that we need to consider. Alright, for example, they've given us that the sum of xy plus yz is equal to 5x minus 1. Well, look, xy plus yz is right here. So according to the problem, that's equivalent to 5x minus 1. So I can replace xy plus yz with 5x minus 1, because xy plus yz equals 5x minus 1. So I'm going to go ahead and make that substitution and write 5x minus 1 in place of this. Now they also gave us another substitution to make. They told us that xz is equal to 13 minus x. Well, xz is right here. Okay, so if I want to, I can replace xz with 13 minus x. So that's what I'm going to do. I'm going to take this 13 minus x and put it in for xz. So this will give me plus 13 minus x equals 24. So I just substituted in the two expressions that we're given. That was the hard part, is setting up this equation. The rest should be pretty simple to you. I'm just going to combine like terms. So in this case, alright, 5x and negative x, those are like terms. So that's going to make 4x. Okay, also like terms. If I do negative 1 and 13, those are like terms. That's going to give me 12. Okay, equals 24. Alright, so of course it's time to subtract 12 from both sides like this. Okay, so that's just going to give me 4x equals 12. Then I'm going to divide by 4 on both sides. So that's going to give me x equals 3. Alright, so but we are not finished. Now we know that x equals 3, but we are supposed to find the length of wy. Okay, but this is a rectangle. So I need you to understand the following. WY, of course, is a diagonal. So this line that I just drew from W to Y, that's a diagonal. So that should be the same length as the other diagonal. So that's one of the properties of a rectangle. The diagonals are congruent. So WY should equal XZ. So let me write that down. So WY should equal XZ. But XZ equals 13 minus X. Okay, so WY equals XZ, but XZ is 13 minus X. But we know what X is now, so we can substitute that in. So that's going to give us 13 minus 3. So that's 10. So, long story short, WY equals 10. Okay, and that is how you do that. Okay, according to the directions, we're supposed to find the length of the sides to the nearest hundredth, that means decimals, 2 decimal places, or the measure of the angles in the kite. Okay, so we aren't given any angles for A, so they must just want the sides. For part B, we're given only angles, so they must want the angles here. Same for part C, they must be looking for the angles. So we'll find the sides for part A, and then angles, and then angles. So, what is one of the main special qualities of a kite? Okay, there are 2 special characteristics of a kite. Can you tell me one of them? Alright, the 2 characteristics are the diagonals are perpendicular, just like in a rhombus. So the diagonals are perpendicular. Also, the one diagonal is an angle bisector. Not both diagonals, that's only for a rhombus, but for example, in this case, MT is going to be an angle bisector. But since we're just dealing with lengths for this one, sides, we will probably wind up just doing the Pythagorean theorem a couple of times. So for example, go ahead and put one over here too. So on this side, if I look at this triangle right here, I'm sort of highlighting in red. If I'm looking at that triangle, I'll go ahead and call this X. So I'm going to be doing X squared is equal to 6 squared plus 5 squared. So that's going to give me X squared is equal to 36 plus 25. That's going to give me X squared equals 61. And then if I take the square root of both sides, that gives me 7.81. Alright, and they did say the nearest hundredth. That's why I'm making it be a decimal this time. Okay, so that means MA, and because of the symmetry, MA is going to be the same thing as MH. So MA equals MH, which equals 7.81. Okay, that's half of the answer. Now we need to figure out what AT and TH are. And I'll call them Y. But I will also change colors. Alright, for AT, alright, so now I'm talking about this triangle right here. Alright, looking at the triangle I just shaded in purple, it's going to look like this. Y squared equals 5 squared plus 8 squared. Y squared equals 25 plus 64. That's 89. If I take the square root of both sides, that gives me that y equals 9.43, which means AT and HT both equal that. So AT equals HT, which equals 9.43. Okay, so that's how you do part A. For part B, in a kite we have symmetry. There's one line of symmetry. So this line right here is a line of symmetry for the kite. Okay, so there's your line of symmetry for this kite. That means angle A and angle H should be the same thing. So whatever angle A is, angle H is going to be the same thing because of symmetry. Well, how many degrees total are there in any quadrilateral? Alright, there are 360 degrees total. So let's start by subtracting the two that we have and see what's left. So if we subtract from 360, minus 74, minus 27, that is going to leave 309. Wait, I messed that up. Minus 27 minus 74. That leaves 259. Okay, 259 degrees. But that 259 degrees needs to be shared equally between angle A and angle H. So the only way to share this equally is to divide it by 2. And that's going to give us 129.5. Okay, so that's the key right here, 129.5. So in other words, the measure of angle A equals the measure of angle H, which equals 129.5 degrees. So this would be our answer to B. Okay, and finally C. Again, a kite has one line of symmetry. A rhombus has two, but a kite has only one line of symmetry, and this would be it. Alright, so there's the line of symmetry for my kite. Okay, so because of symmetry, can you tell me what the measure of angle A is going to be? Yeah, angle A is going to be 118 degrees. If the left side is 118, it's like a mirror image, and that's going to be 118. Aside from that, finding the fourth angle, we're going to do the same thing we did before. We're going to start with our total of 360 and subtract what we have. So minus 118 minus 81 minus 118. See what that gives us. That gives us 43 degrees. Okay, that means the remaining angle must be 43 degrees. So, in other words, the measure of angle A is equal to 118 degrees, and the measure of angle T is 43 degrees. So that would be the answer to part C. And I think that was it. Yep, that's the end of the homework.